Hello everyone, welcome back. Today we're going to talk about a very special equation, and this equation will be covered in the last section of chapter 8, section 8.4. The equation I'm talking about is called parametric equation. So let's get started. So I'm going to put the topic today, section 8.4. Parametric equation. I don't know if any of you heard this term before, but if you first time you heard this and you were like, oh, parametric equation, maybe this is very hard equation, right? Because para, I mean like more, right? Many, right? A metric is like measure, so it's like this type of equation can be measured in something. Maybe you think like that. Well, literally, I can say that parametric equation is the equation it can be used to describe any equation. What I mean over here is that given an equation into variable, and we can rewrite it with parametric equation, and we can rewrite in many forms of parametric equation, not just one form. Okay, but before I jump into what parametric equation is, or I give you the example of parametric equation, let's kind of go back to the first time you learn equation into variable. So the first time you deal with equation into variable is when you do what? Do you remember? That's the first time when you deal with a linear equation into variable, right? In college algebra, right? Y equal to so I'm going to put a recall right here. So the first time you deal with equation into variable is y equal to mx plus b, right? And you know b is the constant and y and x is are variable, right? And this equation represent a line. So this is the equation into variable. And recently you learn conic curve. Conic curve is equation into variable. So the circle is equation into a variable. And ellipse or hyperbola is also equation into variable x and y, right? So you can say that conic equation are a typical example of two variable equation x and y. Okay, in pre-calculus, any equation into variable can be called with another name. So let me just write out. This is the equation in two variable. Okay. So in pre-calculus, any equation into variable we can call the rectangular equation. Rectangular equation. So they have a name for that. So all conic equation is rectangular equation. I can get that's an example of rectangular. So I'm going to put over conic curve equation are rectangular equation. You know, if you heard a rectangular, you're thinking about rectangular coordinate system, right? And this is true because every time you're talking about x and y, you know, you talk about rectangular coordinate system, right? And conic curve contain x and y. It means what? It means that they contain many points, right? And x is the component. Any point can be written as order pair form. Can be written in order pair form, right? And order pair form contain x component and y component. So what I mean over here is that any conic curve equation or any two variable equation, it can be described geometrically in a rectangular coordinate system. Okay, it can be described geometrically in rectangular. So what I mean over here, it can be graphed on rectangular coordinate system. Meaning the coordinate system is what? The coordinate system is an x and y coordinate system, right? Right? Okay, and with x and y component, it means that as long we have a point, and the point has x component and a y component, we draw many points. We look at many points on coordinate system, and we connect all those points. We have a curve, right? Okay, and the good thing is that x and y can be also written as a function of t. So before I can jump to that part, let me give you something more over here. Like I want to elaborate more because I say too much, but I'm not writing many over here, right? Many things over here. So I'm gonna just add a few things so that you remember. So I'm gonna put over here conic curve equation and rectangular equation because it can be described, okay, on rectangular coordinate system. With points, right? And those points has a coordinate could be written in order pair form x and y. And x and y is the x component and y component. Okay, and now I say that x and y can be written as a function of another variable. Okay, and in pre-calculus we have that we name that variable t, and we call that a parameter. Okay, and when x and y can be written as a function of variable t, we call that parametric equation. Okay, so parametric equation is like a system of x and y, and x can be written as a function of t, okay, and y is also written as a function of t, okay, and t over here we call that t is a parameter. Okay, so this is a, okay, not I believe it's a, not e. Let me make sure that I spell them right. Okay, this is parameter. Yes, so it's a. Parameter t. I mean, you can use another parameter if you want. You can use like t, w, whatever you want. So most of the time they use t. Okay. So I have over here is a general form of a parametric equation. So, and as I say that I mentioned that any equation can be written as parametric equation, and parametric equation can have many forms. Okay, for example, I have something like this. Let's say, okay, how about this? I have parametric equation like this: x equal to t squared minus 3t, and the second one y is equal to t minus 1. So this is a typical example of parametric equation, is because you see that x can be written as a function of t, and y can be also written as a function of t. Okay, so this is a parametric equation. All right, or I can give you another example of a parametric equation. Example 2. What if I have something like this? What if I have x equal to sine of t, okay, x equals to sine of t, and y equal to cosine of t. And this is also the parametric equation because it's a function of t and it's also a function of t. It doesn't matter, okay, as long as it's a function of t. It could be trigonometric equation, a trigonometric function, or it could be polynomial function. It doesn't matter. It could be a radical function if you want it. Okay, so this is a typical example of parametric equation. Or I can have something like this. I can have like something more complicated. For example, I have something like this. Example 3. I can have like x equal to 2t plus 5 and y equal to, you see that I'm going to use radical function over here, 4 minus t squared. So this is also a parametric equation. Okay, but I already say that parametric equation represent a rectangular equation. So it means in this example it represents some kind of rectangular equation. In example 2, it also represents some kind of rectangular equation. So does example 3. But we don't know what rectangular equation. We need to figure it out. Okay, we need to figure it out. How we do that? How we do that? Okay. So in the next example, I'm going to show you how to convert. Okay, how to convert parametric equation into its equivalent rectangular equation. Okay, so example 4, the question will be find an equivalent rectangular equation. Find an equivalent rectangular equation for a parametric equation in example 1. Alright, it mean what? It mean I want to convert this into a rectangular equation. So how are we gonna do that? It's going to be very easy, but I mean it still depends on what you can see or not. You know how flexible you are. So every time we talk about converting parametric equation into a rectangular equation, it means what? It means that we want literally. So I'm going to put solution over here first. Let me use different color for that. I think I'm going to use let's use this color. So if the question asks you to convert or find equivalent rectangular equation for parametric equation, it means that literally it means that you must get rid of parameter t. So you have to do some way somehow so that you don't see a t anymore. You don't see a parameter t anymore. Well, if you don't want to see parameter t anymore, all you can do is you solve for t, right? You take one of the equation here and you solve for t, right? And you solve for t, you plug them back here, and all you can see is what? All you can see is just the equation in terms of x and y. You don't see t anymore, right? So all you can do, all you have to do is to do substitution. So from this, okay, from this I'm gonna get t. So t is actually equal to what? T equal to y plus 1, right? T t equal to y plus 1. Then after you get a t, right, you're gonna plug into the first one. So you're gonna replace any t on the first equation with this y plus 1. Then the first equation will become what? X equal to y plus 1 square, right? Right, because we have a square, so everybody know how to do substitution. Minus 3 y plus 1, right? Okay. Alright, so after you plug it in already, right? Because they ask you to find equivalent rectangular equation, it means that we need to find the equation in terms of x and y over here, in two variable x and y over here. So what did you say over here? What did you say over here? You see that this is y square, and you look like this is y, right? Look like we have what? Look like we have a parable, right? A parable, and the highest degree is second. The highest degree in variable y, right? So it means that we have a sideway. We have a sideway parabola. Okay, not the ups, not the vertical one, but we have the horizontal parabola, right? So in order to clarify that, so we're gonna just do some more steps. So make sure that you have to do more steps because this is not clear enough yet. So you have y is 1 plus 2 y plus 1, right? You expand them out, minus 3y distributed, right? Then you kind of simplify this, so you have y squared minus y minus 2, right? Look at that. This is the parabola, right? This parabola in variable y. This parabola in variable y. But it's not in the form of parabola we learn in conic curve. So if you want to do a few more steps, you can convert it into a conic curve form of parabola. Let me see how we're gonna do that. Okay, let me see. Okay. Alright, so first of all, I'm going to add both sides by 2. So this is some extra steps so that I can clarify it is a conic curve, y squared, because parabola is a conic curve, so y squared minus y. So I'm completing the square here. This is 1 divided by 2. You square to give you 1 4, right? So you subtract 1 4. You already learned that in Academy-Toán algebra. So over here, that part over here is a perfect square. So you have y minus 1 over 2 square minus 1 4, right? Then from here, so I'm gonna write over here. Let me write over here. Okay. Then from here, what we have I'm gonna add both sides by 1 4. So you have x plus 2 plus 1 4 equal to y minus 1 over 2 square, right? Is it in the form yet? Is it in the form yet? Not yet. So we need to do a few more steps. Let me see. So over here we're gonna combine this. So you're gonna have a 9 over 4, right? Equal to y minus 1 over 2 square, right? It look like that. This parabola. This parabola over here has vertex which is not at the origin. It's not at the origin. So let me rewrite it. So I can rewrite this y minus 1 over 2 square equal to x plus 9 over 4, right? So this is the k over here, and this is h right here. So the vertex is not at the origin. But it's still not in the form yet, so we need to do something else, because the form is y minus k squared equal to plus 4p x minus h, right? So if I want to write it in that form, I can put like this: y 1 over 2 squared equal 4p, right? So 4p over this k will be 1 over 4, right? 4p x plus 9 over 4. Okay, so the vertex over here will be what? The vertex over here will be this is the sideway. Again, this is the sideway parabola, a horizontal one parabola, not vertical one. So the vertex in this case will be negative 9/4 and 1 over 2. And the P is P over here will be 1 over 4. So this is some extra information, you know. But I mean, as long as you can get it to this step, you got credit. If I'm asking you this type of question on the test, okay, so that is the way you convert parametric equation into rectangular equation. All right. In example number 5, let me see I can convert this into rectangular equation or not. Okay, so example 5. Let's see. Where is this? Let's use this color again. Okay. So example 5. Okay, the question will be converting this. Okay, I want to convert this to a rectangular equation. So we have, let me rewrite the system over here. X equal to sine t and y equal to cosine t, right? So this is a parametric equation, and I want to convert into, rectangular equation. And after I convert into rectangular equation, you will see right away what kind of equation, is that. Okay. Okay. So because you're in pre-calculus now, so all the concept in trigonometry, you make sure that you guys have it already. You will see that if I square this, you will have x squared equal to sine t squared, right? And I square this, so I have y squared equal to cosine squared t, right? And if I add these two over here, so I have x squared plus y squared equal to sine squared t plus cosine squared t. So what do you see? Sine squared plus cosine give you 1. So my final answer is x squared plus y squared equal 1. What kind of equation is that? Oh, it looks very familiar to you, right? Look very familiar to you. What's this called? It's called what? This is this is a circle, right? So this is a circle with center at the origin. Center at the origin, right? Okay. All right. Yep. So this is a circle. All right. So this is a typical way of get rid of the t. You see that when I add them up, this cancel out of t because all you have left is 1 because sine t plus cosine t is 1. You already know that, right? You already know that. Let's see. What next? Okay. So let's see. How about this one? How I'm gonna convert this? Okay. And I want to convert this to rectangular equation 2. Example 6. Okay. So I'm gonna put over here. Example 6. And let me rewrite the question. Right? What a question about? So I'm going to convert this, right? All right. So it will be x equal to 2t. Let me rewrite it. X equal to 2t plus 5 and y equal to 4 minus t squared. Okay. Okay. So how are we gonna do this? So again, our goal in order to bring it to rectangular equation, we need to get rid of the t. So if you, I mean, in order to get rid of the t, you have to do substitution. The thing that over here, you're getting stuck with the radical. So I think that we need to get rid of the radical first, and in order to get rid of the radical, we need to square both sides, right? We square both sides. So from here you will have so from here you will have y squared equal to 4 minus t squared, right? Then from here then from here what I'm gonna do is I'm gonna solve for t, then I'm gonna plug over here. I think that's the one of the best way, right? So I'm gonna subtract both sides by 5 2t, then divide both sides by 2, x minus 5 over 2, right? Then I'm gonna plug over here, then I will have y squared equal to 4 minus x minus 5 divided by 2 totally square, right? Because it's t squared. Okay, and now I'm going to expand the amount, so I will have 4 minus x minus 5 square over 4, right? And if I do LCD, could be 4 at the bottom, right? And over here multiply by, so 16, I expand them out over here, so we'll have x squared minus 10 x plus 25, right? Okay, and I distribute the minus, so we have 16 minus x squared plus 10x, right, minus 25 over 4, right? Okay, then I'm gonna combine that term over here, so I have a negative x squared plus 10x minus 9, right, over 4. So what do we have over here? What do we have over here? Then I'm gonna kick the 4y up here, right? Multiply both sides by 4, so I have 4y equal to negative x squared plus 10x minus 9. Okay. And let's see if this is a good way or not. Or we should keep it. I'm gonna kick number 4 over here. We keep this so that we have in the very beautiful perfect square form, because over here otherwise we have to do complete the square again. Okay, we can do complete the square again if we want to. Okay, so I'm gonna factor negative out. Plus 9, right? Okay. Then I complete the square. 10x divided by 2 is 25, right? Plus 25 minus 25 plus 9, right? Okay, so you will have x minus 5 squared plus 25, and distribute the minus in, okay, minus 9, so you will have negative x minus 5 squared plus 16, right? Then I'm going to subtract both sides by 16, so I will have 4y minus 16 equal to negative x minus 5 squared, right? And If I divide both sides by -1, so I will have x minus 5 squared equal to 16 minus 4y, right? And I factor number 4 out, so we have 4 minus y. I reorder them, so I have negative y minus 4. Here you go. Look like what I have here is the parabola, vertical parabola, right? So because right now what we have, right now what I have is x minus y squared minus 4, okay, for py. What is your p over here? You can write that. You can calculate the p. P is actually 4py. It's 4p 4p was good. It's 1 over, because our remember when we talk about vertical parabola, right? The equation will be x minus h. Remember that one? The equation. Let me use that. Remember this one? Y x minus h squared equal to what? Equal to 4 negative plus minus 4p y minus k, right? So that is the parabola, vertical parabola, which vertex is not the origin. So I try to convert into that. So 4p is actually equal 4p is actually equal to negative 4 right here. So p is 1. P is 1 in this case, right? Let me change. Let me turn back to. Let me go back to y1. Okay. So p is 1 right here. So negative 4py. So the vertex over here is what? The vertex over here will be 5 and 4, right? We find 4. So that is the parabola. It's the vertical parabola. So this is parabola. This is a vertical parabola. Actually, we know that it's negative, so actually it's a negative. It's upside down. It's upside down. Negative vertical parabola, upside down vertical parabola. All right. So that is how you convert it. I mean, it takes a little bit of time, but you get used to it because all you have to do is you just do a substitution, right? It's nothing else. Okay. All right. I can give you another example. Let's see what else can we do here. In the next example, so this right now this is example number 6. So in the next example 7, I give you a rectangular equation. I give you something like this. This is a rectangular equation, and you know right away this is a parabola, right? This is a parabola. So if you rewrite it in the form of a conic curve, then you can write like this, right? Alright, this is a parabola. For p is 1, p is 1 over 4. Okay. Now I want you guys to convert the above rectangular equation into parametric equation. Okay. And I already said before, there are so many ways of getting parametric equation from rectangular equation. So many ways. And the best way is that you just let x equal t and solve for y. So if x equal t, then y will be what? Then y will be what? Y equal to t minus 1 square plus 1. So this is one of the form of parametric equation that represent this rectangular equation. But there's so many parametric equations. That's why we call it para. Okay. For example, if you let x equal to, instead of equal to t, you can let x equal to t plus 2. Then your y become what? Then your y will become t plus 2 minus 1 square plus 1. Then you have t plus 1 square plus 1. Right? So this is also one of the parametric equation represent this rectangular equation. Okay, this represents example 7 rectangular equation right here. The one x minus 1, y equal to x minus 1 square plus 1. Okay. Alright. Okay. So there are many parametric equation, you can get. But most of the time, I always let x equal t because it's very simple. But sometimes you cannot use it. Sometimes if you have some crazy rectangular equation that it's very hard for you to get the y, then you shouldn't do it. Then in that case, I mean, there's some very special way to do that. So I'm gonna talk about that because this could be too much for you guys. But most of the time, you just need to let x equal t, then you solve for y. All right. Okay. Now, let's see what else can we do here. In examples 8, example 8, I want you to write parametric equation. Find parametric equation, okay, for a line, okay, which slope, which slope equal 3 and goes through point 2, 6. Alright, so how are we gonna do that? How are we gonna do this? Solution. Okay, I just want to remind you one thing before we do this. So slope is equal to 3. I mean the rise over run is 3. Rise is y, right? And run over is x. So it's over here. Y is 3 and x is 1. 3 over 1 right here, right? All right. So all parametric equation for let's go through a point is in this form because it goes through a point. Then point 2 or x, and 2 is the x component. Then your parametric equation, you will start with x, right, and y, right? And because it goes through point 2, 6, so you're gonna start x equal to 2, okay? And it goes to 6, so y equal to 6, right? Plus, okay, plus, okay. Then now it depends on the slope. Because the parametric equation contains t, right? So it must have something with t over here. And rise over run, right, is represent the y, right? So rise is 3, okay? And run over is 1, right? Okay? And now we want to get the t. 3t and this 1t. So this is the way to write parametric equation for a line. Okay, so over here you're gonna write the component. You're gonna put that the component of the point which the lines go through, and over here you write down the slope. Okay, you get the slope right here. Alright, so this is the parametric equation for any line. This is going to be in this form. Alright, good. Right? I mean, in order to make sure this is a line, well, you can show t and you plug it in. You know. So this is some extra step. You don't have to do that when you see this type of equation, but I want to write a few more steps so that you know right away this is the linear equation. So this is over from here you can solve for t, so t equal to x minus 2, right? And you're gonna plug over here, so y equal to 6 plus 3 x minus 2. You're gonna replace the t in the second equation with x minus 2, and here we have 6 plus 3x minus 6. So you see the cancel out. Then your equation is y equal to 3x. So that is the line. That is the line, right? And this line goes through the center of the coordinate system, and with the slope is 3. So this is the line. On the test, you don't have it. On the test, you just need this, okay? Because I asked you to find parametric equation. All right. I don't want you to convert this parametric equation into rectangular equation. All right. So I think I'm gonna stop right over here. So this section is not. I'm not gonna say it's easy, but I'm not gonna say it's hard either. It will be very easy as long as you know how to do completing the square. So that's why I say the completing the square is very important. As long as you know how to do substitution. Okay. Next time, next video, we're gonna start with section. Let me see. We will be doing section chapter 11. Okay, we'll be doing chapter 11. Because chapter 8, 9 and 10 is about trigonometry, in Valencia, in native school, I believe that they split it up into trigonometry and pre-calculus. So we will be starting with chapter 11, and we'll be start with the first section, sequence and series. Okay, I will be see you there. Bye bye.